In this session, we are going to compare mohr-coulomb model, constitutive model, and HS or hardening soil constitutive model. Of course, for modeling in plaxis 3D, one of the main stages here is choosing the constitutive model. There are some different constitutive models in plaxis 3D, and mohr-coulomb and hardening soil model are two main important models for choosing in modeling. First, we discuss about mohr-coulomb constitutive model. Mohr-coulomb constitutive model is a elastic, perfectly plastic model. It means that relation between strain and stress is firstly linear elastic, and after that it changes to perfectly plastic. If you want to see, we can, for example, draw that. Like this. This is a stress-strain relationship, and this is mohr-coulomb. Mohr-coulomb relationship between stress and strain is like that. Firstly, it is elastic. After that, after reaching the failure situation, it will be perfectly plastic. But in hardening soil, relationship between stress and strain is nonlinear from the first. So it drawing that, we can see that relationship between stress and strain is like this one. So it is completely nonlinear from the first to the end. This is the main difference between these two models, and this is HS or hardening soil model. And something that is important for comparing these two models is that before reaching failure condition, mohr-coulomb model only behave elastically, and there is no plastic strain in the material. But in HS model or in hardening model, constitutive model, before reaching to failure condition, we have a strain, plastic strain. It means that if we have unloading and reloading before reaching to failure situation, we will have plastic strain. So this is a very important difference between these two models. And if we want to compare these two models, we can say that in soil we have real condition, real behavior, nonlinear behavior, and it is similar to hardening soil. It is nearer to hardening soil constitutive model, because soil in reality behave nonlinear, and it is like this one. So we prefer this model to mohr-coulomb model. We prefer hardening soil model to mohr-coulomb model because it is nearer to reality. The second difference between these two models is that a stiffness parameter is stress dependent in hardening soil. In hardening soil model, we have stress dependent stiffness, but in mohr-coulomb model, we don't have a stress dependent stiffness, and the stiffness is constant. So this is another difference between these two models. We can say that, for example, if we want to write, we can say that the stiffness is a stress dependent in HS, but not in mohr-coulomb. This is very important, and one of the main differences between these two models is that stress dependent stiffness is considered in HS model, but not in mohr-coulomb constitutive model. And in reality, we know that stiffness is stress dependent. So hardening soil model is nearer to reality and is preferred to mohr-coulomb model. Another difference is that another main difference between these two models, between HS model and MH or mohr-coulomb model, is that in isotropic stress condition, when we increase the stress, we don't have any failure in mohr-coulomb constitutive model, and this is not compatible with the reality. If we want to draw that, we can draw it. For example, stress situation, if this is shear stress and this is mean stress, we can draw the failure condition. Failure condition and failure situation is like this in mohr-coulomb. This is mohr-coulomb failure condition. This is failure criterion. This is failure criterion in mohr-coulomb model. As you see, when we are here in this line, if we increase stress, without any shear stress, it means that isotropic stress. If we increase isotropic stress, we are in this line. So if we increase the stress, we don't reach to failure criterion, and there is no failure in this material. It means that if we have a very big, very large stress, we won't reach to failure criterion, and this is not real, and this is not compatible with the reality. But in another model, that is hardening soil model, we have something like this relation between tau and sigma is like this, but there is a cap here. There is a cap here, and this is main difference between these two models. This cap is main difference between these two models, and it calls that if we move on this axis, if we increase the stress, we reach to this cap and the failure happens. So failure happens in isotropic stress condition. In isotropic stress condition, we will have failure in HS model or hardening soil model. This is HS model. So in HS model, we have failure criterion, we have failure condition in isotropic stress situation. And this is very important difference between these two models. Another main important difference between these two models is modeling stress path. Stress path is considered correctly in HS or hardening soil model, but it is not considered correctly in mohr-coulomb model. The other main difference between mohr-coulomb and hardening soil model is considering loading and unloading, reloading and unloading and reloading in these two models. Unloading and reloading is considered in HS model, but it doesn't consider in MH or mohr-coulomb model. As we can see in curve between porosity and logarithm P, for example, in consolidation curve, we can see that the slope of curve in unloading and reloading in this part is different with loading part, after, of course, pre-stress load. So this thing can be modeled in HS model, but it cannot be considered in mohr-coulomb model. So in HS model we have this, but in mohr-coulomb model we don't have this part. As we can see, hardening soil model has some main advantages to mohr-coulomb model. So usually in modeling with plaxis theory, it is preferred to mohr-coulomb. But there is a significant problem. Although the behavior of these two models before reaching to failure line is totally different, but in failure situation, both of them follow mohr-coulomb criterion. So we can conclude that in modeling with plaxis, when the situation is not in failure mode, the behavior of HS is more realistic than MH, but in failure mode, both of them are the same. In another point of view, we can say that if deformation is important for us, HS model is preferred to mohr-coulomb model, because in deformation, a stiffness parameter has key role, and this is key factor, and a stiffness parameter is considered more appropriate in hardening soil model.